Hello and welcome back. In this lecture, we're going to talk about the exponentially linear unit, or the ELU activation function. So we saw ReLU last time, and for all negative values, the output is 0. Now for ELU, for all negative values, you have an exponential function. As you can see here, this is an exponential function. So rather than having a flat line at 0, as in ReLU, then in ELU we have an exponential curve for all the negative values. So this is the equation for an ELU. So when the value is positive, it's the same thing as ReLU. It stays the same. It's a linear function x. And when the values are negative, then we have an exponential function, which is e to the power of x minus 1. So why is it minus 1 and not only e to the power of x? If you have a look at the graphs for e to the power of x and e to the power of x minus 1, then as you can see, when it's e to the power of x, and if we take a look at the negative values, which we're interested in because here we have an exponential function for the negative values. So for the negative values, as you can see, then we have some range in the negative axis, which is from negative 2.5 to 0. And in this range, the output is a positive value, as you can see here. So for example, when you have a negative 1, then the output is a positive value, which we don't want. So what we need to do is shift the graph down by subtracting 1. So when we have e to the power of x minus 1, then this is the graph that we have. And for all negative values, we get an output of a small negative value, as you can see here. So for all negative values, the output is also a negative value, and this value is very small, as you can see here. So the range of values that this exponential curve can have is basically from negative 1 to 0, okay, which is from here to here. So for all negative values, we get an output of a range between negative 1 and 0. And the more negative we go, then the more the output will lean towards minus 1. So this is the exponentially linear unit. For negative values, we have an exponential function of e to the power of x minus 1. And here we also can optionally scale this exponential function by this parameter alpha. And here we can set this parameter alpha. So if we don't want to use it, we can just set it to 1. And if we want to use it, we can set it to some other values in order to scale this exponential function. So for example, sometimes people use 1.3, which scales this exponential function. So this is the derivative of the ELU activation function. If you derive x with respect to x, then you get 1. And if you derive alpha times e to the power of x minus 1, then you get fx, this function right here. So basically the derivative is going to be alpha times e to the power of x minus 1 plus alpha. If you derive this with respect to x, then this is what you get. And finally, this is a comparison between the ReLU activation function and leaky ReLU, and finally ELU, which is the exponentially linear unit we talked about. So the purple line here is ReLU, the green line is leaky ReLU, and the blue curve here is ELU. That's it. Thank you very much, and I'll see you next time.